session going to discuss about metal casting. Myself, Mr.S.Parmasivam, Assistant Professor, Department of Mechanical Engineering, PS College of Engineering Technology, Autonomous. The first, the introduction, a process based on the property of liquid to take up of the shape of the vessel containing it. A cavity of desired shape is made containing in a mold, carried out in the foundry. Have you seen any similar process before? What do we control the casting process? The size and shape of the cavity and mold. Next, the mixed composition of the casting. Next, the temperature and cooling time, and carefully remove it. The requirement of casting: a cavity of the desired shape in a mold, and next the molten metal and a proper channel to fill the molten metal. Before the basic casting process, the first step, here a two-piece split pattern is used. One of the split pattern is placed at the center of the molding board as shown in figure. The top box is placed around the pattern. The towel pins are connected to the top box. The 20 mm layer of pacing sand is first placed around the pattern, and the track is filled up with green sand. The next, the successfully ramming is done by the pin end of the hand hammer. During ramming process, if necessary, additional sand can be put into the track. Later, the sand around the pattern and these edges of the molding parts are rammed with the help of the butt end of the rammer. And next, the excess sand is removed by strike off bar. And next, the vent holes are made by vent wire, which is used to escape the steam and gases produced during pouring of the molten metal. And the top surface is made smooth by trowel. Then the trough is tilted upside down as shown in figure. The parting sand is sprinkled over the pattern to avoid sticking of the pattern with the molding sand. Also, it avoid sticking of the surface of the green sand on hoop with the sand or track. The top half of the pattern is placed correctly in position. The hoop box is placed correctly in position on the track using towel pins. And the riser pin and screw pin are placed in the correct position. Then the operation of the filling, ramming and venting of the sand on hoop are done similar to track. The screw pin and riser pin are removed. Then the pouring basin is formed at the top of the hoop box to facilitate the easy pouring of the metal. The hoop and the track are separated. Then the track spike is driven into the pattern pieces and shaked lightly. Then the pattern pieces are withdrawn slowly. A gap is done on the top surface of the track. It should be exactly below the spool on the hoop. Then the mold surfaces are coated with coating material such as graphite to get smooth surface to the casting. Then the core is set in the position if necessary. Finally, the hoop and track are assembled. Weight is placed on the hoop to prevent the hoop from floating up when the molten metal is poured. Now the molten is ready for the pouring. The basic terms used in casting. First one, pattern. Pattern, it means the model of the casting part. It means the replica of the desired part. Next, the mold. Mold is a container with a cavity within, divided into two halves, hoop and track box. Next, the casting system. Network of the channels that deliver molten metal to the cavity. Basic steps in casting process. First one is pattern making. Next is mold making and melting of the metal and pouring, cooling and solidification of metal, cleaning of the casting and inspection. In material used for pattern. Pattern is the replica of the desired product and has a different dimension than the AC actual part to be manufactured, used to form the mold cavity. First, material used, next type of patterns and pattern allowances. In pattern materials, what are requirements need? easily shaped, worked and machined or joined, resistant to wear and corrosion, resistant to chemical action, dimensionally stable, easily available and economical. First pattern material, first one wood. Wood is easily availability and low weight and low cost. Can be easily saved. Wood, more than 90% of casting use wood patterns. Absorb moisture, so distribution and dimensional changes occur. Relatively lower life, hence it suitable for small quantity production. Next pattern material is metal. Metal used for large quantity production and closer dimensional tolerance. And longer life, aluminum is mostly used and other metals are cast iron, brass, etc. Next pattern material, plastics. Low weight, easier formability, smooth surface and durability. Do not absorb moisture, so dimensionally stable, corrosion resistance. The next topic to pattern allowances. In pattern allowances, trap and taper allowances. Taper provided by the pattern maker on all vertical surface of the pattern so that it can be removed from the sand without tearing away the side of the sand mold. And inner detail of the pattern required higher draft than outer surface. Commonly applied draft allowance is 1 degree to 3 degree. Due to draft allowance patterns can easily removed from the mold box. And pattern, the trap and taper patterns, amount of the draft depends upon the length of the vertical side of the pattern to be extracted and intricacy of the patterns and method of the molding and pattern material. And next allowances is machining finishing allowances. The finish and accuracy in sand casting is generally poor. The extra material provided on the casting to enable their machining or finishing to the required size, accuracy and surface finish. So it is added in pattern dimension. Allowances is provided only in machining area. The amount of machining allowance depends upon the method of the molding and casting and size and shape of the casting. Next the casting orientation, metals used in casting, and finally degree of accuracy and finish required. Next the distortion and camber allowances. Due to the difficult shape of the casting get distorted during solidification. The distortion is absorbed in irregular casting so that it swings in uneven manner. The distortion are caused by internal stresses which are generated on the account of unequal cooling of different sections of castings. So to be avoid this distortion allowance is provided. It is varies from 2 to 20 mm allowances. Next allowances is wrapping or shaking allowances. Before the withdrawal from the sand mold, the pattern is wrapped all around the vertical faces to enlarge the mold cavity slightly, which facilitates its removal. When pattern is raked, mold cavity is enlarged. To account for this increase and pattern size is reduced. This allowances is important in large sized casting and precision casting. The amount of wrapping allowances depends upon the extent of the wrapping and degree of compaction of sand and size of the mold and sand type. In tools used in carpenter tools and some pestle tools. First is the contraction scale. It is used to measure the pattern dimensions, include various allowances. It is metallic scale of 300 or 500 mm length. And combination set. It is generally used for pattern making. It is used to measure angles, perpendicularity and locate the center on cylindrical shape. Calipers. They are of internal and external type, generally used to measure internal and external diameter of patterns. And ratchet press. This is used to drill holes in horizontal and vertical plane. Wheel press. It produces only small holes. It can drill small holes and accurately and quickly. Backsaw and plane. They are used for curtain and pattern operations. And color coding for pattern. Pattern are colored by using shellac acid paints. So colors give protection and identifies the features of the patterns. Color scheme given as below. The black color it means indicate unfinishing surface on the casting. The red color indicate finishing surface on the casting. Yellow indicates it means core prints. Black it means parting surface, and red and yellow strips are seeds for loose piece. And color molding. The damp molding process is referred to the method of making the mold and material used. Molding process have certain features in common. First one, use of the pattern. Next, some type of aggregate mixer compressing a refractory and binders. A means of forming the aggregate mixer around the pattern. The horning of accurate or developing its bond while in contact with the pattern. And withdrawal of the pattern from the mold, assembly of the mold and core pieces to make complete mold metal, then being poured into the mold cavity. In classification of molding process, the molding is based on the mold materials used for. There are three types: sand molding, metallic molding, plaster molding. And another type is based on the methods used for bench molding, bit molding, floor molding, and machine molding. And types of molding sand. In green sand, the natural sand prepared as a mixture of silica sand with 18 to 30% of clay and 6 to 8% of moisture. And green sand fine, soft, light and porous. The name green sand implies for tamped. It contains moisture, and the mold made of this sand is used immediately to pour the melted metal. Easily available and has low cost. And another type of molding sand is dry sand. The green sand that has been dried or packed in between 250 degree to 550 degree in suitable oven after the making mold and cores is called dry sand. Dry sand more strength and rigidity and thermal stability. Dry sand suitable for larger castings. And next, parting sand. It is used to keep away the green sand from sticking to the pattern and to allow the sand at the parting surface of the planks to separate without clinching. The parting sand is free from clay and dry. Parting sand washed and non-sticky sand. In cold sand it means used to make a pour. Should be stronger than the molding sand. It is made by mixing core, its oil and silica sand. It is also called as soil sand. And packing sand. Packing sand it usually contains band-to-band facing sand and molding sand and clay. It is older and repeatedly used sand and used for packing facing sand. It is filled behind the facing sand in the mold box or flask. Next, the passing sand, it is mixture of floor sand and new molding sand with suitable binder and moisture. It is used next to the parting surface and comes in the contact with the molten metal when poured into the mold. It is used around the pattern to cover it up to 2.5 to 5 cm. And next, properties of molding sand. The first one, the refractiveness. Refractiveness means the ability of molding sand to withstand high temperature without breaking down or fusing. The degree of refractiveness depends upon the SiO2 content and shape and grain size of the particle. To enhance the property, and sand should have lower percentage of the lime, magnesium and alkali and oxide of metals. Refractiveness is measured by sinter point rather than its melting point. At sintering temperature, the molding sand otherness to casting. And next, permeability. It is also referred as porosity. Is the property of sand allow the escape of any air, gases or moisture present or generated in the mold when the molten metal is poured onto the head. Liquid metals cause evolution of gases to their reaction with the molding sand ingredients. Permeability is a function of grain size and grain shape, moisture and clay contents in the molding sand. The next question is also referred to as strength of the sand. It is property of molding sand by virtue of which the sand grain pot indicates interact and attract each other within the molding sand. And molding sand should be capable of withstanding the compressive and erosive forces exerted by the liquid metal while filling up the cavity. The low strength molding results in defective castings. It depends upon the grain size and sand particles, shape and size, and moisture content and density. Strength and inversely affect the porosity. Next, the flowability. It is the ability of the sand to get compacted and behave like a fluid. It will flow uniformly to all portions of batten when rammed and distribute the ramming pressure evenly all round in all directions. In general, flowability increases with the decreases in grain strength and decreases in grain size. Flowability also varies with moisture and clay content. It is also called as plasticity and fluidity. Next, the other is the property of molding sand to get stick or other with foreign material such as sticking of molding stand and inner wall of the molding box. It helps the sand to retain the mold cavity and stay in the box. The collapsibility after the solidification of the molded metal, the casting is required to be removed from the mold. If the molding sand is easily collapsible, the free contraction of the metal as well as easy removal of the casting is possible. If the sand is collapsible, it will strongly adhere to the casting, becoming very hard to separate after metal solidification. The next, the core and core prints. Core is a metal or sand body which is set into the prepared mold before closing or pouring. These are used to produce holes, projections, cavities in the castings. Core is kept on seat in the mold box prepared by the batten. Some projections is made in the molding box during molding process. These projections made on the molding box are known as core print. The next, the type of the core: horizontal core, vertical core, balanced core, cover core and drop core. First one, the horizontal core. As per the name, it keeps horizontally in the mold box. It is positioned along the parting line. It is commonly used in foundry. Next, the type of core is vertical core. It is placed in vertically in mold box and it occupies scope and track. Both the ends are rest in the core, seat provided in the scope and track. Both the ends are tapered and maximum portion is located in track. The next, the balanced core. Only plain holes or holes which are open at the one side are produced by balancing casting. Balanced core has only one core print to maintain the alignment of core. The next, the core print and a portion of core outside the mold cavity is kept slightly larger and heavier. The cover core, it is supported on the track and completely molded in track. Core serves as cover to the mold. The trough core, it is used to produce holes in casting above or below the parting line. Taper is provided to slide up the core with the placement. The elements of gating system is spool, pouring cup, riser, gating, core and mold cavity and cope, trough, core print. The types of molding, the first one is bench molding. In this method, the small mold are made upon the bench. It is used to manufacture the cream sand and dry sand mold. Loose piece patterns are used for this bench molding process. The ramming is done manually and slow process and requires levers. It's having types: 2 box molding, 3 box molding, stacked molding. And next mold type is floor molding. It is used for medium and part casting. It's carried out on the floor. In this molding, floor is act as a track and cope box is rammed. It is time consuming and requires labor. Green sand and dry sand mold are made by this method. It is also called as bending. Example: wheels, pulleys, plates with ribs or etc. In pit molding process, large casting of the manufacturing is used. Pit is stuck in the floor of the boundary with the bed of the charcoal placed at the bottom of the pit to help the escape of the gases. Hope is placed over the pit to complete the assembly. The sand is rammed and the wall of the pit are pricklined and plastered with lime sand. Molds are packed before the pouring. The gates, runner, riser, pouring basin are made in coke. The cranes used to lift the coke and position over the truck. In machine molding, it is suitable for large productions. It consists of following steps. First step is ramming up the sand by jolting or squeezing in the mold, rolling up the mold through 180 degree and drawing up the pattern from the mold by rising or lowering the mold halves. The types of machine used for making molds: jolting machine and jolt twist machine and sand slinger. Next is the types of casting methods. First one is centrifugal casting. In this process, mold is poured and allowed to solidify during revolving. Due to the rotation of mold, the poured metal is subjected to the centrifugal force. The centrifugal force is allowed molten metal to flow in the mold cavity. Hence, metal is deposited on periphery of the mold and starts sophistication. Lighter slag, oxides, inclusions are get separated and moves towards the center. In centrifugal casting, there is no use of the gates and runner and risers. The axis of the rotation may be horizontal or vertical. In centrifugal casting application for pipes, cylindrical liners, bearings, bushes, gears, flywheels and conveyors, etc. The next molding types, casting types, cell molding. This process is used for smooth surface finish. It consists of tump box which is partially filled with silica and the thermoelectric resin. Then the tump box is sealed with metallic pattern which is preheated about 250 degrees Celsius. When the tump box is inverted, mixer is get melted and forms the cell on the pattern plate. Cell thickness varies from 5 mm to 8 mm. These two cells joined together to form complete the mold. In application of cell molding, small pulleys, motor housings, fan plates, cylinders, cylinder heads and brake drums. In investment casting, it is also known as lost wax casting, precision casting. This method is used for manufacturing jewelry, dental goods. It involves following steps: making up the wax pattern. Sometimes mercury or plastic may be used. Provide wax made gates, runner, riser to the pattern. The complete wax pattern put in the box and filled with the liquid mold material. The liquid around wax pattern solidifies and form mold. Then the mold is heated to 150 degree to 800 degrees Celsius to remove the wax. In application of surgical instruments, vans and plates for gas turbine, costume jewelry, wall bodies, respirating slides for cutting machines. In casting defect, following are the casting defect arise during the factory process in casting: flow holes, pin holes, shift, short trans, hot gears, hold sets. In flow holes are spherical, flattened or elongated cavities present in the casting. They are formed due to the following reasons: the rapid evolution of gas from mold and lack of porosity in mold bags, excess moisture in sand and hard ramming of the sand. The remedies action of the flow holes: molds and cores are properly vented, avoid hard ramming, proper amount of moisture in sand and proper grain size of the sand. In pin holes are small holes of less than 2 mm diameter which are on the surface or below the surface of the casting. The causes for the pin holes: high pouring temperature and next gas dissolved in molten metal. Gases are not removed properly from the molten metal. Sand with high moisture content. In remedies for the pin holes: maintaining the pouring temperature, increase flux propagation and reducing moisture content in sand, effective regarding. Next, the shift. This external defect arises due to misalignment parts of casting. The causes of the set: core displacement, misalignment of cope and track, burnout and burnout of the clamping pins, misalignment of two welds of patterns. In remedial action for the repair and replacement of dowel pins, proper alignment of patterns, proper alignment of cope and track, repair clamping pins. In short run, it is also called marine. When cavity in mold is filled incompletely, then short run introduced. In causes for the short runs, the insufficient of the metal supply and lack of the fluidity in molten metal. Molten metal's temperature is low and fault casting system. In remedial action for the adjust pouring temperature, adjust rate of pouring, modification in casting system. In hot layers, it is also called as pulse and hot rod. The may internal or external, the having dark blue in appearance on the surface. In causes for hot layers, the lack of compatibility of core, high temperature of castings, incorrect design of packing system, lack of fillets and cornerability. In remedials is improved design of casting, improved compatibility, proper solidification, correct pouring temperature. Thank you.